Yes, I'm here to help you on how to balance combustion reactions of hydrocarbons. Yes, involving alkanes, alkenes, and alkynes. All right. So, many students in Nigeria universities and late secondary school, they find this aspect very, very difficult because this kind of reactions actually attract fractional coefficients, and that's the problem. So now there's a formula that will help you, and you also can know how to apply such formula whenever you are trying to balance this equation. So first of all, you know, aliphatic hydrocarbons are hydrocarbons that are strictly made up of carbons and hydrogen, and it involves alkanes, alkene, and alkyne. And as you can see, they have a formula that guides this kind of compounds: CnH2n plus 2 for alkene, CnH2n for alkene, CnH2n minus 2 for alkyne. All right. Now, a typical example of an alkane is ethane, C2H6. And what is unique to alkane is that the number of hydrogen will always be twice the number of carbon plus 2. So if you said the number of carbon is 2 now, twice it, that's 2 times 2, 4. Then add 2 extra, that's 4 plus 2, 6. That's how you know that is an alkane. And you know that an organic compound that has 2 carbon is 8. Because it's an alkane, you call it ethane. So let's say, for instance, ethane undergo combustion reaction. Combustion reaction is the reaction of any compound with oxygen, and it will always produce, for alkane, it will always produce CO2, carbon dioxide, and H2O water. Right? It's always a constant result. But your own duty here is to know how to balance these equations. What are the coefficients you have to put in front of each of the reacting species? That is the major work here. Right? So let's say, for instance, ethane combusts with oxygen to produce carbon dioxide and water as seen. And we are asked to find, let's say this place is A, B, C. We are looking for a number that can perfectly fit in front of these reacting species to give us a balanced equation. But we don't attach anything to the hydrocarbons. Don't put any number here. You are only expected to add something here, add something here, and add something here. So how will you get it? Look at this formula at the top. This formula is a very, very straight formula, and that you can always apply. So you see that everything here, they are very, very straightforward except the n. So what you're supposed to ask me now is, how can you get your n? Your n is the number of carbon. So in this case, the carbon involving the carbon coming from the organic compound given to us, ethane, is 2. This 2 here, that's your n. So for you to get, for oxygen, O2, just input 2 in place of n in this formula. If you do that, if you put 2 here, that will be what? 3 times 2, which is what? 6. 6 plus 1 will give you what? 7. 7 over 2. So you have to write that 7 over 2 here. To get the number of CO2, the n is 2. And we said n is always the coefficient of CO2. Just write the 2 here. For you to get the coefficient of water is n plus 1, which means you will add 1 to the coefficient of CO2. When you add 1 to the coefficient of CO2, then you have gotten the coefficient of water. This is a balanced equation. Very simple. So if I were you, the first thing I will do is, I will first balance the CO2. The CO2 is the number of carbon given. The carbon cannot increase and cannot be decreased. So as the carbon is coming from here 2, the carbon is supposed to carry 2. Then the next thing is to find the coefficient of water. Anytime you want to find the coefficient of water in alkane, you are going to increase the coefficient you have given to CO2 by 1. 2 plus 1 is 3. The last one that is always difficult to find is the O2. And the O2, just use this formula, 3n plus 1 all over 2, where your n is 2 in this context, because the number of carbon given is 2. If we have used another compound like propane now, that is C3H8. If we have used C3H8, our n will have been 3, not 2. Alright, please take note of that. Now, that is how to balance a chemical equation that involves the combustion of alkanes.